How can you visualize datasets with thousands of dimensions? Imagine trying to see the shape of a mountain range when all you have are tiny pieces of a puzzle. That's what visualizing high-dimensional data feels like. When data has thousands of features, it's impossible to see it all at once with your eyes. But there are ways to make sense of it. In machine learning, especially in unsupervised learning, we often need to reduce the number of features to understand the data better. This process is called dimensionality reduction. It helps us turn complex data into something we can visualize and interpret. One common method is called principal component analysis. It finds the directions in the data where the most variation happens. These directions are called principal components. By keeping only the top few components, we can create a simplified version of the data that still holds most of the important information. Think of it like summarizing a long story into a few key points. This way, you can plot the data in 2 or 3 dimensions and see patterns or clusters. Another popular technique is T-distributed stochastic neighbor embedding. It focuses on keeping similar data points close together in the new space. This method is especially good for visualizing how data naturally groups or forms clusters. It creates a map where similar points are near each other, making it easier to spot patterns. Then there is uniform manifold approximation and projection, which is similar to TSNE but often faster and better suited for larger datasets. It also preserves local structures, helping you see how data points relate to each other in lower dimensions. Sometimes, instead of just points, you want to see relationships across many features at once. Parallel coordinates is a technique where each feature gets a vertical axis, and data points are drawn as lines crossing these axes. If many lines run parallel or cross in certain ways, it reveals patterns and connections. Scatter plot matrices are also helpful. They show pairwise relationships between features in a grid. Each small plot compares to features, helping you spot correlations or outliers. In machine learning, visualizing high-dimensional data helps recognize patterns, find outliers, and evaluate models. It's like turning a complex map into a simple diagram that guides your decisions. When working with such data, it's important to consider ethics. Make sure your visualizations respect privacy and avoid bias. Always check that the methods you use do not distort or misrepresent the data. Tools like ChatGPT, DALL-E, and Midjourney use visualizations to understand data better and improve their outputs. For example, visualizing how features are distributed helps AI models make smarter decisions. Productivity plugins can also use these techniques to help users manage large sets of data more easily. So, when you face datasets with thousands of features, remember that techniques like principal component analysis, T-distributed stochastic neighbor embedding, and uniform manifold approximation and projection are your best friends. They turn overwhelming data into clear, visual stories you can interpret and act on.